Thank you very much. Thanks for the opportunity to come and to present a little bit about an NSF project that is open and people can get involved with. They could try out and log in and get accounts and try some exploration. So hopefully this is a introduction to the kinds of things that might be enabled and students might find interesting to explore. So that project has been in various forms for more than 10 years now, starting really with the Array of Things project that Charlie Catlett started. And the concept is that if we move computation out to the edge, out to where instruments live, that gives you a new set of capabilities. You can analyze the full resolution data. You have network and bandwidth problems that you can get around, and you can process that data, obviously, in situ. So the SAGE Grande project is a version of this project to deploy 300 nodes around the country. The previous version of this project was a MSRI, and so that had deployed more than 100 nodes. Some of those nodes are still available. You could get online and look at those nodes. And the idea here is that we will embed AI, especially inference, out to the node, out to the edge, and let you, anyone who uses the system, try to develop new AI and new data types and run stuff out at the edge. So the project is a large project distributed across the country. I'm a single speaker here today, but really that represents the team, everyone from people in California here, Ilkay in San Diego, to Jason in Hawaii and others. So it's a large distributed team, and that distributed team has parts that are working on AI, and also parts that are doing deployments of nodes out in the wild, in wilderness areas. So what does that look like? What does a deployment look like? Well, this is a node from NEON. NEON is a very large NSF project that is analyzing and collecting data about climate and the ecosystem in the United States. And this is an instrument hut. And in the past, those instrument huts were fairly simple. They just collected data from instruments. Because you can't send all the data, because there's not enough bandwidth, they sample some of the data and send some of that data out to be archived. What we do is put a GPU and a server in the instrument hut. Now the full resolution data can be processed, and you could write Kubernetes containers that run inside that node and compute. And that can run in an instrument hut, or this is in Lahaina after the fire destroyed part of the city. There was a push to put a node here in Lahaina that could understand both new threats, new wildfire threats, but also pollution and understand what's happening with the city. Here is nodes in Chicago and university teams putting these together. So inside each one of these boxes is a GPU. All right, so what does that look like? I've described some of the parts. I'll just name things now. It's a pretty straightforward thing. If you had a paper and pencil and said, hey, I could design one of these, you probably could, right? It's straightforward, which is, there's a place where we have code that it's in a repository. You can think of this as the App Store. Right? This is the place where you get a container and you push that container out to the edge. And then out at the edge, the computer code can run and analyze data in real time. And in the past, and this is now the subject of this talk, is sort of how this is moving into the future, is that in the past, it took a pretty skilled computer scientist to write AI code that could run at the edge. You have to know, one of the Python AI libraries. You have to have maybe fine-tuned a model. There's a lot of work that was required. It wasn't impossible, but we couldn't just go straight to domain scientists and they would jump right in. It took a while. But we have had success with atmospheric scientists and others writing their own AI for that edge. However, large language models have transformed that. It's made it possible that AI-ready data, that data can be analyzed and even code written for the edge by using an LLM, or by just using prompts to analyze what's happening at the edge. So I'll show some examples here. So first, just a couple examples of when I say run code at the edge, you might think, well, what does he mean by that? What kind of code? What would I run at the edge? I don't know. So here are just some real tangible examples of people who have run code at the edge. These are students or postdocs. This code would do wildfire detection, and we'll show something like that. Chris Lee in Hawaii is working on volcano detection, which is even more exciting maybe. There's folks who have worked on connecting really large LiDAR to do automatic steering to analyze 3D wind turbines offshore. And examples like using the Cornell bird model. If you're familiar with the Merlin app on your phone, that's running a model that listens to your microphone and tells you what bird species you might be hearing. So this is an example of that code running on a real node. This is a Sage node running in Illinois, and it's running out at a prairie site by a river. And here's the GPU is up here, and there's a microphone, and we can run that model in real time, 24/7, detecting, for example, birds. But this is just one application. It's really a general purpose computer, so it can run 5 or 6 or 10 applications all in turn. An application might look at cloud motion. It might look for wildfire. It might analyze images. So those are the kinds of things when we talk about running code at the edge, what that means. And that opens up the door now, the question to the community here, right, is that if you're a computer scientist, you could use this infrastructure to explore fine-tuning models, building new models, federated learning, self-supervised learning, quantization of models, guardrails, lots of topics. It's a test bed, so it's open to try those ideas out. However, if you're a domain scientist, maybe you're interested in actually detecting wildfires or analyzing bird song or looking for when wildflowers bloom and finding out if that's changing over time. So our project partners with domain scientists who do this kind of work. This was a deployment that we did a couple years ago in Hawaii in Volcanoes National Park. So these are students, undergrad students. And that is not an undergrad student, but the guy who's rated to go up a tower with ropes and equipment. And installing the Sage node up there, now that Sage node is running code that PhD students can write. And a good example of that is this piece of code. So here on top of that tower, it's in Volcanoes National Park, so it's looking at the volcano, Kilauea. And so now from that tower, you can look over here and we see this plume of smoke. And you can imagine that in the previous world where a computer scientist has to write a special purpose AI, they go off and do that for several months, right? In the new world where models like ChatGPT and Qwen and DeepSeek and others are multimodal, you can say, oh, I'm going to give you an image, come up with a caption. And so here, is a very simple, the query is there a fire or not, right? Is there a volcanic eruption or not? And in this case, here's an image taken from the Sage node where there's a volcanic eruption. And so all of those apps that we have been running, those pieces of code that you might run at the edge, there's an opportunity now to imagine AI and natural language interacting with the data in real time, asking questions of the data rather than writing a special purpose code. And so this example here that I showed has evolved over time. Now this is not our photo. So we're not allowed to get that close to the volcano, but the US Geological Survey is, and this is what they're showing during that eruption. One thing I had no idea about volcanoes, but because of the deformation of the surface of the volcano before what's called a fountain event, they can predict this. So we were getting alerts, 2 or 3 days ahead of time saying, hey, there's going to be a fountain event in this weekend. Make sure your cameras are all set up, right? So this is the camera that we have at that tower. But this is a really great example here. So here is the regular RGB image. Here's the infrared image. Of course, at night, we can't see anything, but the infrared image still shows the glow. And a model called Moondream is being run at the edge, and then the students hook this up to a Discord channel. So now they get Discord notes when the volcano is erupting, right? So this is the kind of thing that this infrastructure provides, is people to start to explore, how would I plug large language models, how would I plug these things together and do it in real time, just typing and trying out new prompts. Another example here is, this is a deployment in the Tetons National Park. And this particular deployment has no volcanoes nearby, although if you know the Tetons, there's a super volcano underneath all of that space, but none of us will live through that if it erupts, right? But there are mammals, and there is a pan-tilt zoom camera that has a 30x zoom. And so some students and other staff worked on writing an autonomous agent for the camera. Here, the camera identifies that there's something near the building and zooms in. This is the zoomed in photo here. And then continues to take photos and track the animal day and night. And we see that, it's an elk, and eventually we get a picture and it shows an ear tag, right? So this elk has been tagged before. But these are all pieces of code that regular users can start to write themselves, because these codes are simple Python codes that are manipulating AI components. And in the sense of AI readiness for data, another project or thing that's happened recently is, imagine taking all of the data that you have and then beginning to process that through AI models and making a database out of that. So that's something that we've done with our project. So we took all of the data that was already from the nodes, processed that with captioning and other AI tools, put that into a vector database. That vector database, then you can type queries in natural language, and it goes through the vector database, picks out the images that match, and then runs over and grabs those images and sends them to you. So this is another example of, when we talk about AI-ready data, what can we do to take data that we're getting, annotate it sufficiently that then you can hand it to models to build databases that then you're querying the database for the AI features that it sees, and not trying to look by hand, looking through thousands of images or audio or anything else. And this uses infrastructure that Frank talked about just right before lunch, using NRP, the National Research Platform, and other pieces. And I want to wrap up here I want to make sure we have time for a couple questions, and point out that, how many of you, just with a show of hands, have tried to write code using an AI tool? Okay, great, everyone has. Right? How many of you have looked back through the code and gone, okay, sometimes it's great. It's like, wow, I asked for a simple thing, a unit test, or write a Python converter that does this, and it works. Well, there are tools that are happening now to make that writing of code easier. Of course, there's a bunch of startups who have been doing this, right? Cursor, Warp, others. There are open source versions, Klein, OpenCode, I think is another one. There are a bunch of projects in that space. One's called Open Hands, I think. And they're pretty remarkable. What they do is they allow you to pull information in about your project in some form, and then wire your large language model in so that you can ask questions and write code. So we've done that for the SAGE project. So if you wanted to, you could, right now, during a break sometime, not during the next talk, but during a break, you could grab a copy of one of these tools. Cursor is one that you could try out. That's one I'm using here on the screen. And then you hook it to our SAGE server. It's called an MCP. What that does is it populates the context of your large language model, telling your large language model everything it needs to know about SAGE. So then you can start asking questions of SAGE. You could start saying, hey, I would like to write a piece of code that does this, or I want to find data that looks like this. So these are examples of real natural language text that you could write in a window that using the MCP would help find and actually run a function call like was discussed earlier and run and help you with your code. So let's just look at some of these. So you might say, here's one, I'm studying pollinator activity. What SAGE data would show me, air quality or temperature or pressure? Or you're curious about that pan tilt zoom feature I showed. So you'd say, show me some plugins, those are the names for codes that run at the edge, that work with pan tilt zoom cameras. And then it would show you the code repository and you could start looking through that. Or you might say, gee, I'd like a statistical summary of biodiversity metrics. I'd like to look at the bird calls. So this idea of being a co-developer, a co-inventor, sitting with a large language model that knows about your project while also exploring the data and trying to write code is I think it's very fascinating, and it will be certainly a kind of future space for cyber infrastructure hooking in, and also, as Frank described, what classrooms will be like, right? You'll write code and you'll be talking to a large language model to help with ideas. So I'm going to wrap up now. We occasionally have workshops, the last one, virtual workshops to sort of get your hands dirty, log in, try stuff out. You could do that. Sign up for our next one. We'll have one in the spring. You could also go up to this Get Started button and click that and get an account using the NAIRE portal and ask for an account. Or you could sign up for office hours as well and just sort of talk to somebody if you're interested in trying things out. There also are some, of course, there's plenty of tutorials and web pages available. So let me just summarize so we have time for discussion. So the first thing is that what I've described is a test bed. Now that's special NSF speak, special code word speak, right? So a supercomputer center like what Frank was talking about earlier, SDSC, they have very strict metrics about what their uptime is, how many users they need to serve, what efficiency of the supercomputer is. That's a difficult job. NRP allows for more of a flexible platform. It's a test bed kind of space. SAGE is in a similar situation, meaning it's okay to try stuff out and break things. That's the idea of a test bed. You're exploring what's possible. It's not a resource designed to give you cycles like, oh, I need 1,000 GPU hours. That's not the right place. If you're going to try new ideas, this is a place to try new ideas. So what kind of ideas might you try? Right? Well, you might try setting it up to run LLMs out at the edge or captioning things at the edge. What would that look like to process your data with a special purpose model at the edge? Volcano erupting? Yes or no? Tell me, right? Is it flooding? What's happening with the river? What's happening with the air quality? Or adding your own sensors. Exploring agents and autonomous control, this idea to be able to move and adjust things in real time. That's, this is all low risk. It's not like adjusting your insulin in real time, so we won't have to worry about that. But moving a camera, adjusting the sample rates, these are easy things. Explore AI for data analysis, this AI-ready data concept. Can it be that you use a test bed to explore your ideas about how do you tag and annotate your data in real time with AI so that other people can use it? So finally, I'll say that we've partnered with a lot of deployment groups. So in San Diego, in the mountains, they have wildfires in San Diego. They have wildfires here too, but in San Diego there's plenty. And so we've partnered with a group there that puts SAGE nodes up on the mountains where they have wireless relay stations. NEON, as example, in Oregon, we have an agriculture network. I think we're going to be working with Eva and team on that's in Colorado looking at drought. And so if you have a group that is interested in deploying SAGE nodes, in other words, the GPU and hooking it up to sensors, you should also come talk to me. because we have 300 that are being deployed over the next couple years, and our first batch of, about 30 to 50 are being fabricated right now, of the new nodes. And the new nodes are going to be NVIDIA Thor based. So they're really quite powerful GPUs. They have 128 gig of RAM on a package that does maybe 60 watts, right? So you can put these in remote places and really explore interesting ideas with that. So with that, I think we have enough time for questions.